Hello, everyone. Thank you for joining us. This is our first tech talk for women in data science, Mumbai and Kerala chapter. I have been the ambassador for with Stanford from 2018, and it is a huge honor to continue doing this year as well. Sadly, due to the pandemic, it's all virtual. Otherwise, we would have had physical conferences where everybody would get together and be able to see the speaker live. But we are again grateful to all of our speakers who find time to do this. And just a very short introduction, we have these live sessions on, say, once a month. We have our next one in April. We had the first inaugural keynote session by Bushra last. It was on the International Women's Day. Today we are having the pleasure of hosting Akankshha. She is a data analyst at Google, and she's from the Trust and Safety Group. So there's a lot that you can learn from her, and it is indeed a great honor that we are having her today to talk about machine learning in the payments industry. And it is the entire concept of WIDS, that is, this entire platform is to showcase what I believe, me and my team, everybody believes, is to showcase how data science can be used in different variety of domains, be it retail, banking, cryptocurrency, whatever it is. There is data everywhere. Every company is a data company. So how do you use data science? How do you use data analytics to actually solve problems, real world problems? That is what we want to bring to you through these talks. So without any further ado, I would like to welcome Akanksha. Hi, Akanksha.
Hi, Hi, Julian. Thank you so much for the warm welcome.
So it's all yours. Everybody's yours.
Sure. Thanks. First of all, welcome everyone to Women in Data Science Session 2022. It's a great pleasure and honor to speak over here. Thanks, Julian, for giving me this opportunity. And thanks to everyone who has joined this session. I personally feel it's a great initiative to spread more information and knowledge about data science. It is one of the most buzzing technologies and one of the most promising technologies that we are seeing in the last few years. It has immense number of applications, and in the foreseeable future I see nothing but the applications of it increasing at an exponential level. So it's a great initiative. Kudos to everyone who's a part of it. Now, a quick introduction about myself. Julian has already given, but I'll just talk a bit more detail about the work that I do. So I'm Akankshha Aggrawal. I work in Google as a senior data analyst. My job is to fight fraud and abuse in the Google products that are there, and also at the same point of time making sure that the products are safe and secure for the users that are using our products. We use technologies like machine learning, statistics, and analytics to fight fraud and abuse. So that's about me. Now, today we'll be covering what is machine learning, what are the use cases of machine learning, why do we feel that there is a need of machine learning in the payments world, and what are the use cases of machine learning in the payments world. So we'll be talking all about that. Feel free to add in any question or comment that you have, and I'll try to respond to it as soon as possible. So yes, so okay, let's get started. So let's start with what is machine learning. So uh, before we go to the definition of machine learning, I would just say, I think machine learning, data science, artificial intelligence, blockchains, these are the terms that we all have been hearing everywhere. And it is present, I think, almost everywhere. And in be it any sector, be it IT, be it banking, be it healthcare, be it finance, one or the other technology is being used and is proven to be very useful. And we have seen its applications, and we can see how important this technology is today in all these sectors. And more so, it's not an exhaustible list. There are many other sectors which is using machine learning. And these are the big sectors, where we see, okay, proper ML model in place, and also, but in a day-to-day application for an everyday customer, like for example, you pick up your phone, you click a picture, Machine learning is there. You pick up your phone, you use the face unlock feature. It's the machine learning that's the underlying technology behind it. We'll be talking about it in detail though. The self-driving cars initiative that many companies are taking, the underlying technology behind it, again, machine learning. Every one of us are over here must be looking at OTT platforms and looking at movies and series. We get a list of the recommendation of the next movies and series that you can watch. What is the technology that is helping us giving this recommendation? Again, machine learning. So like in our everyday life we see how machine learning is applied and how is it used. So it's a very interesting field altogether. It has great depth, great nuances, great details. We unfortunately will not be able to cover everything in today's session, but I'll try to give you an overview of how it works and how machine learning is used in today's world. So most of you over here must be knowing about machine learning, but folks, for the ones who are new to it, I'll be just talking about machine learning. I'll try to explain it in as simple terms as possible with examples, so that we understand what is actually machine learning. So machine learning is nothing. It's just a tool which converts information to knowledge. Now, information is getting converted into knowledge. So, what is information? Information is nothing but the data that is around us. In the last 50 years, we have seen a huge explosion of data happening. Data is everywhere around us, but are we making correct use of that data that is around us? uh, until and unless we are analyzing the data, we are trying to find out the patterns that are behind the data, the complex patterns that are hidden there. Data is of no use no use to us, but we can make a lot and lot of improvements with the help of the past data. But imagine for a human to analyze the entire data that is there. It is a very complex task because the quantity of data is so huge, and a human eye will not be able to uncover the hidden truths and the hidden underlying patterns that are there. So now what is the solution to it? How to make this information useful to us so that we can we can make use of that past data in other application. So here is where machine learning comes into picture. So what machine learning does is machine learning analyzes the data. It analyzes the data. It finds the valuable underlying patterns that are present in the data, and the complex and the data is actually very complex. So to find out the underlying patterns, it's a complex job. Machine learning helps us do that. It helps us uncover the truth which otherwise one would have struggled to discover. So it gives us that information that a human eye might not have been able to, and that is what machine learning does. Also, apart from analyzing the data and also finding out the patterns, what it does is, based on that data analysis, it helps us predict a future event and also make a complex decision. It also helps in making us it also helps in making a decision making. So that is what machine learning does. I'll try to explain this in a more clearer way with the help of an example. So, for example, we talked about the face unlock feature. Now, what is happening over here? Now, we said that machine learning is the underlying application in that. So we pick up the phone, we use the facial face unlock feature. Uh, Apart from the owner, if someone is trying to unlock the phone does not gets unlocked, it remains locked. But if the owner is trying to unlock the phone using the face, it gets unlocked. Now, what is happening? So when we install an application of face unlock feature, it asks us for some pictures. Now that pictures is actually the data that is the data that I've been talking about. So now that data is the information that the machine learning model is actually using. Now, once that data is gone, the machine learning model analyzes the patterns, it analyzes the facial features. And now, when the owner is trying to open, what machine learning model sees is, okay, the data that has been present with me, I see that there is a match. Okay, so the decision taken by the machine learning model over here is yes, unlock the phone. Whereas if someone apart from the owner tries to unlock, what it sees is that okay, the information that I can see right now is different from the information that is fed to me. So what the answer is, no, the machine learning does not unlock the phone. And that is how machine learning is actually helping us in making decision making. So that is the power of machine learning. So, apart from that, there are various technologies that are being used in machine learning. Also, I would just want to add one more point to it. That is about, like, okay, machine learning converts information into knowledge, but how is it converting information into knowledge? I'll use a very naive example over here. The way a child is being raised, the way we constantly tell a child, okay, this is to be done, this is not to be done. And it is not that once we told, the child stores it and acts accordingly. It's always that we have to give him a lot of information, and that is when it registers, and that's when child slowly and steadily acts as per the instructions given to the child. Now, what happens is, similarly, is a machine learning model. In a machine learning model, it's not that at the first go, it will, like, you say, okay, this is to be done on this, when this information there, machine learning will not follow it. So you have to train the model. Now, how do you train the model? You give them as many information, as many data as possible, as long as you're storing more data, as, like, you're refreshing more data, you're giving new examples. The machine learning model is learning every day. It's learning from the data that you're giving, and as and when we'll give them more applications, more data, more nuanced scenarios, it will learn and it will give us more accurate results. So that is how a machine learning model is also learning. So that is what is machine learning. Now, there are various terminologies that we are used that is being used in machine learning. You must have heard the word data from me a lot many times. Another term is data set. Now, what is the difference between data and data set? So, as I said, that there has been an explosion of data. Like, there is a humongous amount of data, but we cannot give that data as it is to an ML model. It will not be able to feed in that data in the first way it has been received to us, and that data has to be converted into a data set. Now, when we say data set, that means that, if, for example, in the data that we have, there are 50 features, but we feel that out of the 50 features, 10 are not important for the model, we have to remove those features. If we feel that there are missing values in the data, we need to see how do we impute those missing values. We need to make sure that the data is clean, the data is balanced. So that is when a data, when cleaned properly, is converted into a data set. Data cleaning is one of the most important step, and it's the first step in building a machine learning model. If the data is not clean and the data is not correct, whichever more sophisticated model we'll take, we will not be able to achieve a high accuracy or precision. So it's very important for us to take a very important to make a clean data and help us and feed that into the model. Now, data set are of two types. One is the training data set, and the other is the test data set. So let's understand about it with the help of an example again. Let's take the example of, we need to build a model whether it will rain tomorrow or not. A very simple one. Now, when we're saying about whether or not it will rain tomorrow, uh, in order to predict that, there will be some input that is required. Now, what will be the input? So, for example, from a layman perspective, if we talk about, what is the region where you are in, like, where you're in if I talk about India, where are you, in the north, south, east, and west, because all have the different patterns of raining. What is the season that is there, like, if it's the rainy season, if it's the monsoons, if it's the winter season, or it's the summer season. So, the probability of raining is as per that. What has been the humidity, what has been the average temperature for the last 3 days, what has been the minimum temperature, what has been the maximum temperature. So all of that. So now the fields that I've just said, like, minimum temperature, maximum temperature, region, location, season, month, these are nothing but features. So these are the features. Now, imagine along with these features there is another feature which says, uh, okay, these are the number of roads, these are the number of cars in that city, for example. Now, that is another data that is present to you. But when you're talking about predicting whether it will rain or not tomorrow, the number of how many cars are there will not be affecting the raining pattern. So that is the feature that has to be excluded. And for that, we require SME knowledge. So uh, when we are converting a data into a data set, we need to exclude some features as well, which we feel are not very important for us. So these are the features that we have talked about. So, and the feel and features is another very important terminology over here. And this is what these are what the features are. Now, regarding data set, we said about training and test data set. So now, the data set over here, for example, I'm trying to predict whether or not it will rain tomorrow based on last 1.5 years of data. So what I do is I take 1 year of data, I train my model on that. So now that 1 year of data is nothing but the training data set, because with that data, the model will be learning. Okay, what happens in the monsoon season? In north side, if the month is August, the probability of raining is 90%. In north side, if the month is, for example, say March, the probability of raining is 30%. So that is how the model will learn based on last 1 year of data. Although in practical application, 1 year of data is very less, but I'm just considering a hypothetical scenario over here. Now that is the training data set. Now the other we have is a test data set. So why do we need a test data set and what is a test data set? So you must have heard, like, okay, this model has an accuracy of 90%. This model has a precision of 95%. How are we calculating that? So once you train that model, we have another data set which is called the test data set. Now the model is trained, the model knows that okay, with this input this is the output, that is the model has learned. Now what we do is we have another last 6 months of data with us, we feed that input to the data. Now we know in the last 6 months whether it has rained or not in that particular day. We feed that information to the model. The model gives a decision based on what it has learned on the last 1 year of data, and will say, okay, based on what I've learned, I would say that it will rain on this day, it will not rain on this day. Now, what we have is the model's output, and what we do not, and what we have is the actual output with us, what actually happened. So, based on that, we can calculate how precise the model is. So, that data set which is actually used to calculate the precision and accuracy is nothing but the test data set. So whenever we have an entire data set with us, we have to break it into training and test data set. So we can take a 9 is to 1 ratio or 8 is to 2 ratio to break that data set. Now, so that is about training and test data set. The other terminology that we use is features, which I've already talked about. It's very important to have all the valuable features in the data set to have in order to have a very accurate model. Now, the third terminology is model, which we're using since the start. So, model is nothing, but it's the output that you get after you have trained an algorithm. So, over here, as we said, like after inputting 1 year of data, the model has learned and we have built out an algorithm out of it. The output that is given to us, that is what the model output is. Now, there are different types of models. Uh, there is classification model, there is regression model, and we'll just talk about these two. Um, Now, what is the difference between a classification model and a regression model? I'll just talk about very briefly on these two. I'll touch very briefly on these two top and these two models. So, when we said whenever the output is in binary format, it's either a zero or a one, a true or a false, a yes or a no. It's a classification model. Whereas whenever the output given by the model is a number, it's a regression model. So, for example, again, predicting whether it will rain or not tomorrow. That's the answer can be either a yes or a no. So it's a classification model. Whereas if we are trying to build a model which tells us what is the probability that it will rain tomorrow, whether it's a 90% probability, whether it's 80, it's 70. So basically the range is 0 to 100, and we say like what is the probability that will rain tomorrow, and the output given by the model is a number to us. So that is nothing but a regression model. So these are the basic differences between a classification and a regression model. There are different types of models. There is linear model, there is KNN model, is random forest, decision tree. So there are many different types based on the use case we choose a model. So it's present in both classification and regression, and we can use that. So this is basically what is a classification model and what is a regression model. Now, just a last statement on what, like, on the definition of machine learning. As I've said before, it's undeniably one of the most powerful and influential technologies in today's world. uh, I its applications its applications are humongous, and I'm sure they will keep on increasing in the future. So it's good to know more about it. It's something which evolves every day. Every day I open an article, I see something new happening in this field. So it is evolving really, really fast. So, and it's a very interesting field as well. So yes, so that's about machine learning. Now we'll talk about machine learning in the payments world. So what exactly is payments world? So whenever money is involved, whenever there is a customer to customer transaction, merchant to customer transaction, customer to merchant transaction, for example, or money is being spent to purchase a commodity or to purchase services, that is where payments come into picture, and that is what the payments world is. Now, why do you think, like, what are the problems that the payments world is facing, and why do we think that machine learning can be a solution to it? So, one topic that we'll discuss about is uh, in all these payment transactions, first and the foremost thing that we're trying to fight is identifying, like, how to fight fraud and abuse that we see in this payments world. Like, there are many types of frauds, there are many types of abuses that we see. So we are growing in technology, we are digitizing, we are in a era of digitization, we are moving towards digital payments. If in India at all we see, we have like, we must, like, in the last few years, if we compare, I have actually gone from being a completely cash person to a cashless person in the last 5 years. And with COVID hitting us, the need of online transactions has increased even more. So we are becoming more tech savvy. But one unfortunate side of it is, as we are learning more technologies, we are putting more sophisticated technologies, so are the fraudsters. They are having like, their way of hijacking an account, their way of creating uh, fraud is also getting more sophisticated with the advancement of technology. So we need to be one step ahead of the fraudsters in order to fight the fraud that is coming via them. So machine learning is one such solution to fight the fraud and abuse. So one application of machine learning is how to identify fraudulent transactions, how to secure the transactions, and we see a lot of online transactions happening these days. So how do we do that? So we'll talk about how machine learning is helping us do that. So as I talked about, we're moving towards digital payments. More and more customers are doing online transactions. The number of customers using online transactions have increased. The number of online transactions have increased. Now, for a human to identify whether a transaction is fraud or not based on the past history and seeing the tremendous growth in the number of transactions, it's not a feasible solution. We cannot increase our manpower parallelly, in directly proportionally to the increase in the transaction that we are seeing across. So in this time of global uncertainty, machine learning is emerging as a propeller for the digital businesses. So I'll I'll start by explaining this, like, how machine learning is helping us with the help of an example. And this is a personal example. I've actually witnessed it myself. So I am someone who uses credit cards. So I have two credit cards from one bank. One credit card was issued to me, like, I was using the credit card for last 2 years, and there was another new credit card which I issued. Now the bank had my transaction history. They knew what kind of transactions I made. So my average transaction was 3 to 5 k in a month. Once or twice a month, there can be a transaction of 10 to 12 k. So that is how the transaction history has been. Now I was issued a new credit card, and what I saw was that a transaction of 50,000 was made on the first day itself. As soon as the transaction was made, a call and a message was received from the bank asking that whether have you made this transaction or not. And guess what? I had not made that transaction. That card was just issued to me, and I see that there has been a transaction on that card. And by chance, it happens, a message comes to your card, and it was an international transaction. There was no requirement of an OTP as well, and I missed that message. But I'm so glad that they called and they asked me, and then and there it was rectified. So how do you think that that transaction got flagged? Was it a human sitting behind and seeing that, okay, this person has done all these transactions and this does not match the history? No, it was machine learning. So machine learning actually helped in flagging that transaction and telling that, okay, this transaction seems to be a fraudulent one. Let's confirm from the customer whether it's a fraudulent transaction or not. So this is the power of machine learning. So machine learning is actually, it's and the most amazing part is it is such a scalable and automated solution for all the uh, growing online transactions. So manual checks where it's not possible, it's machine learning, and it can give us the result. So that is how machine learning is being used to fight fraud and abuse. Apart from that also, machine learning helps us giving us a customized solution to customers. So nowadays customers are very specific, they have their own needs, they have their own patterns. Machine learning analyzes those patterns and gives recommendations and suggestions to the customer based on how their history has been. So that is another use case of machine learning. It helps us in predicting the customer churn. So basically, how many customers will be using the services, how many customers will end up not using the services, how many customers will end up paying the amount that they are owed, how many customers will not end up paying the amount. So that also helps us in estimating that, okay, how much losses can there be. So this is how machine learning works, and these are the applications of machine learning in the payments world. So now, how do we implement that? So if I talk like strictly about the payments world, how do we implement machine learning? So I talked about the features in the start. So the most important, so when we are trying to build a model, to build a machine learning model in order to identify fraudulent transactions, for example, say, the most so again, when you're trying to build a model, the most important part is model training. Now, when we're talking about model training, we need to talk about data set. Now, what does that data set comprises of? It needs to comprise of the valuable features. Now, the major task is how do I identify those features that we will be using. Now, the most important features that will be used to train the model is customer identity. Who is the customer? What has the past records of the customer been? So, customer identity, the order information, how many orders has the customer placed in the past, uh, payment information, for how many orders has the customers paid us money, for how many we have not seen any payments, have we seen any refunds. So, all of that is the customer payments information. What is the location from which the customer is accessing the account? So all of this information, all of these features are the main features that are helped in payment processing and to help us build the model. And once that is done, we again use a training data set for the model. We train an algorithm on the training set of the historical data. Once that training phase is complete, there is a finished model that is there and which can start identifying fraudulent patterns. Now, as I said, there are various types of models. First, we need to choose whether we want a regression or a classification model. The second part is which model do we want to use. Now, based on the data, based on our application, we choose a model. Like whether do we feel that there is linear regression model is the best model, or do we feel a random forest is the best one? So we need to make those decisions. Also, another very important thing to highlight is whenever you're building a model, the next important step is whether how is that model performing. So, accuracy may not always be the best measure to see how the model is performing, because if the data is, for example, an unbalanced data, accuracy is not always the best measure to realize that. So, in those scenarios, we need to rely on precision or recall or the F1 score. And also, there are other measures like ROC, AUC, RMSE. So, based on the model, based on the use case, we also have to decide what will be the metric that will help us tell that which model is actually, how the model is actually performing. So we need to make sure that we're choosing the correct model, but we also need to make sure that we're choosing the correct metric to evaluate the model that we have built, because unless we have that, we will not have a clear idea of how the model is performing, and we may end up building a model which might not be a good one, but because we chose the incorrect metric, we feel that okay, our model is performing very well, or vice versa. We have built a very nice model, but because of the metric that we have chosen, we feel that okay, the model is not performing good. So it's very important to choose the correct metric as well to see is the model correct or not. So also, like for precision and recall are the two most used metrics in machine learning industry. So need to make sure that whether you want to concentrate more on false positives, if yes, go with precision. If you're concentrating more on false negatives, go with recall. Or do you want to trade off of both of them, then use a F1 score. So that is how you need to choose the metric and the model that is being used based on the data set, based on the application, and also the SME knowledge. So that's very important. So yes, that's all about machine learning and how do we use machine learning in the payments world. Thank you, Julian, for giving me this opportunity. I hope everyone would have learned something from this.
Absolutely. Thank you so much for that. We do have a few questions. I'll just highlight them. I think you can see them on the screen. Anmol Mittal had asked somewhere in between when you were describing differences on how you'll have to distinguish between data that's used for training and for testing. So, if there's anything specific for the payment industry that you use a different way of training, could you just shed some light on that? The question is, how do we train?
Okay, so what I'm understanding is the question is how do we train the data, or
Yeah.
how do we segregate training and data, test data set?
No, how do we train the data?
Okay, uh, so basically, we train the model and not the data. We select a training data set that is there to train the model. In payments industry, again, as I said, features are a very important selection. We cannot take all the data, all the features that are present to us. We need to make sure that we have to select the valuable features that are present that can help us increase the accuracy. So that's how we select the features. We make sure that the data is clean. There are no missing values. If there are, is the best way to remove that feature column as it is, or should be imputed. Now, imputation can also be like, use a median imputation, use the mean of the values that are there and add it there. Again, SME knowledge is again how we use that, and that is how we train the data. And Anmol, there are different techniques of training the data. As I said, that you have, for example, you use a linear model. So in linear model, so you use all the features that are there and you apply that linear model, and that is how it will help you in training the data. So you can use Python for that. Python has the pandas library. It has a very strong library. Even if someone does not know a lot about coding, you can actually just install those libraries. There are a few commands that you need to write, and your model will be trained as it is. So just go through it, and you will be able to train the model successfully.
True. Thank you for that. Mansi has asked the next question. How do we define a model is good based on the input and output?
Okay,
I
so Uh, so Mansi, whether a model is good or not, it's based on the test data set that I talked about. So once we have trained the model, we use another data set, which is the test data set. So imagine for like 2018, for the year of 2018 to 2019, you have trained the data. Now you're using 2020 data as a test data set. Now you have the actual outputs with you. Like I'm again going to go with the rain forecasting example. You know whether it rained on 1st March 2020, and you see the model is saying that did not rain on 1st March 2020. So the model, that was a wrong evaluation by the model, and that's how you see all the evaluation for 2020. Now, based on how many correct evaluations the model had, and based on how many incorrect evaluations, you can find whether your model is performing good or bad. But again, another very important point to take care of is, this example is where you're forecasting whether it will rain or not. But for example, imagine you're working in a healthcare industry, and the direction is whether the person has cancer or not. In that, you cannot afford to have false positives. You cannot afford to tell a customer who has cancer, and you tell them you do not have cancer. So that you cannot so that ways your model needs to be very precision heavy. It might not be recall heavy, but it needs to be very precision heavy. So based on the use case, you need to see how which metric you're choosing, and then you can see whether the model is performing good or bad. In practical scenarios, if your model is also achieving an accurate, it's a precision of 75 to 85%, it's a good enough precision. You do not achieve a 95 to 100% precision model in practical life.
Thank you for that. So I also circulated a form to collect questions, and there is a question on will so with the upcoming blockchain and cryptocurrency and all of that that's changing the world as we know. Do you think it'll be a far safer world for us, or do we have to be even more cautious?
So I took a session on internet safety a few weeks back, and all I can say is that we are growing in technology, and as I said, fraudsters are also using that advanced technology. So we can rely on the system that we are using, but also we need to make sure that we are also taking the precautions to, because we are using so much of internet, so much of digitalization. We need to make sure that we are also taking our precautions. Change your passwords every month. Keep a password which is a bit difficult for the fraudsters. Do not click on links where you think that might be a phishing attack, and be a bit aware about it, and one should be good to go. So you just need to be aware of what kind of frauds are happening and how to secure yourself from it. The company is doing their part, but then we as the end customers also need to do our part in order to make our transactions digitally safe and secure.
Hmm. Got it. Thank you for that. There was another question. It says payment related data are confidential. So, how is the data related to that collected around this domain? I think he or she, whoever has written this, is referring to how do we use. I think banks have access to that kind of data, but it's supposedly confidential. So,
Yeah, so it's confidential data, and I won't be able to comment much on it. But yes, there are some NDAs that are getting signed, and based on that, the data, whichever the customer also like accepts in the toss violation, the toss basically while you're subscribing for any services, agrees to,
mm,
that is what is being used at the back end to make a decision.
got it. There's another question on, can you give us an example of a fraud pattern that you discovered and how do you combat it? Let me just show it. Yeah.
Um, that is a very specific question, and sorry, as a Googler, I will not be able to reveal that information. So yeah, I'll pass this question.
The other question is, what algo do you use to detect fraud? Is there anything generic that people can use on a fraud finding project that they want to start?
So one thing that has proved to be very useful is anomaly detection. So as from the example also that I said regarding the credit card fraud transaction. So based on the pattern that you've observed, if you find any anomalous behavior, That is something which can be very easily be able to help you detect fraud. um, you can use models for that, and you need to use supervised learning. If you're using unsupervised learning, you have to make sure how do you impute for the actual values. Once you have that, you can build a prediction model or a forecasting model and anomaly detection model, and that is a good way to detect fraud, I would say.
I think, and this is the last question in my list. For someone starting out on machine learning, in a fintech company, the domain of the company is finance, what would you recommend ramping up on first?
Uh, I would say, uh, so that's how I started my journey on machine learning. I would say take up a course where you can find what are the various aspects in machine learning. So, machine learning is a huge field. I know everyone cannot learn everything on machine learning, but what are the basics of it? So, for example, I talked about data cleaning. That's the first part. Now, in data cleaning, also, there are many other details that are associated. So, take up a course which walks you through what are the basic 5 steps in machine learning. Once you know those 5 steps, after that, you can always go and read about those things in detail, or for easy purposes, subscribe a course which has the details in it, generally which gives you all the details. And machine learning at the back end is using actually mathematics. So you will go back to your days of high school, where you learn about what are the vectors and everything, and how are they actually. So in school we used to be like, we are learning maths, but how are we using maths in everyday life? So how we're using these vectors and all. So this is machine learning is actually is an application of all the mathematics that we've learned in our high school. So, but those courses are generally paid courses. So once you know the structure, first thing I would recommend is know the structure and see, are you that interested in the field or not? Because before investing a lot of money, we need to make sure that yes, this is something we want to pursue. From outside, something might seem very interesting and very attractive, but once you go in details, it does happen that okay, you do not feel that connected to the field. So once you gain that understanding, then you go purchase a course and learn about the details of it, and start with, for example, say classification model. More that's a more useful model, and which is being used more across. So use that, learn about that, and once you've done that, you can always learn more details. You can uh, like I can provide you some resources as well if you want, and those can be very helpful.
We'll share across whatever resources are shared by the speaker. And thank you so much, Akanksha, once again. This has been really
Thank
helpful, and you've broken it down in as simple terms as it can be. I think everybody's taken away a lot from this session. So thank you for your time. Thank you so much.
Thanks a lot,
Thank
Julian.
you.
Thanks a lot. Thanks everyone for joining, and thanks for giving me the opportunity. I really enjoyed giving this session.
Yes, same here. See you, everyone. We'll have our next talk on April 9th. It'll be 10 a.m. in the morning. Do sign up or subscribe to the channel. You'll get a notification. Thank you, everyone. Bye.
Thank you. Bye bye.